Hi students, welcome to the science class. In last session, we discussed about in the chapter motion, what is velocity, what is speed, what is average velocity and what is average speed. And also we discussed some of the problems on average velocity. V is equal to u plus v divided by 2. It is nothing but initial velocity plus final velocity divided by 2. And also we discussed some problems on average speed, that is capital V is equal to s divided by t, that is nothing but total distance covered by the object in time t. Okay, now in today class we are going to discuss about what is acceleration and what is uniform acceleration and what is meant by non-uniform acceleration, what are the examples for uniform acceleration, and also we discuss some of the problems on acceleration. So now I am considering first point, acceleration. What is acceleration? Before going to tell what is acceleration, now imagine that you are in a bus. You are in a bus. It moves from a bus stand. It moves from a bus stand towards another station. So imagine that it starts with a very slow velocity. I am considering here the bus starts with about 10 km/h from a bus stand. 10 km. I am considering it is a bus stand. It is out of the city. Here this point is out of the city. I am considering here it as a O, that is out of the city. When the bus starts to move, the velocity of the bus will be 10 km/h. But when it comes to at the point of out of the city, that is at the point O, when it reaches out of the city, the velocity of the bus will be 60 km/h. Isn't it? It is also in practical. So when you are going to any other places by the buses, so clearly observe when it moves from the bus stand, when the bus moves from the bus stand, it has the very low velocity, very slow velocity, about 10 km/h. But when it reaches out of the city, there is no traffic. So in that places the velocity of the bus will be very more, that is about 60 km/h. Isn't it? Here is the change in the velocity, isn't it? The initial velocity will be 10 km/h and the final velocity when the bus reaches out of the city, the velocity of the bus will be 60 km/h. I am considering the bus takes about 10 minutes to changes its velocity 10 km/h to 60 km/h. It means that the bus takes 10 minutes to cover that distance, to cover B to O, and to changes the velocity 10 km/h to 60 km/h, isn't it? So I am considering at the point O, bus has 60 km/h. Imagine that you are in the bus. When the bus covers the city, when it is a bus will be there out of the city, the speed of the bus will be very high, about 60 km/h. But when it starts to move, the velocity of the bus will be 10 km/h. See, the important point is here, how much time or how much velocity will be increased in 1 second to reach 60 km/h from 10 km/h. Clearly you have to observe here, the bus moves with the 10 km/h. After 10 minutes it attains the velocity of 60 km/h. To attain 60 km/h, how much velocity will be increased by the bus from 10 km/h per second? Have you got understood? How much velocity will be increased in per second by bus from the 10 km/h to attain 60 km/h? That is nothing but the acceleration. So what is meant by acceleration? That is nothing but the rate of change of velocity. The rate of the rate of change of velocity per unit time is known as acceleration. The rate of change of velocity per unit time is known as acceleration. Now what is the expression for acceleration? Now considering here, imagine, see, that is acceleration is equal to A is equal to change in velocity. Why? Because the definition itself says the rate of change of velocity per unit time, that is change in velocity per divided by time, that is equal to acceleration. A is equal to change in velocity. Now consider, imagine an object. Imagine an object moves with the initial velocity. Consider an object which moves with initial velocity u, and it attains final velocity v meter per second in time t. Consider an object, it moves with the initial velocity u and it attains the final velocity v in a time intervals t. Then the acceleration of the object A is equal to change in the velocity. Is nothing but final velocity minus initial velocity, that is change in velocity is equal to final velocity minus initial velocity divided by time t, that is time. Therefore acceleration of the object A is equal to, here what is initial velocity? Here substitute the values. Acceleration A is equal to final velocity v minus initial velocity u divided by time t. This is the required expression to calculate acceleration of an object. Have to remember, acceleration of object A is equal to final velocity minus initial velocity divided by time t. You have to remember what is acceleration. The rate of change of velocity in a unit time is known as acceleration. So what is the expression for acceleration of the object? Expression for acceleration of the object A is equal to v minus u divided by time t. Here v represents the final velocity and u represents the initial velocity and t represents the time. And the SI unit of acceleration, SI unit of acceleration is meter per second square. Also we write it as meter per second square. Acceleration, SI unit of the acceleration is meter per second square, or meter, we can write it also in this type, meter per second square. You have to remember here, acceleration should be taken as a positive. Acceleration should be taken as positive if it is in the direction of velocity. So acceleration should be taken as a positive when only if it is in the direction of the velocity. What it means? Consider here, a bus moves with 10 km per hour. A bus moves with 10 km per hour. It attains 60 km per hour after 10 minutes. I am considering here, see here, what it happens, the velocity in this direction, and also acceleration also it is in this direction, that is it increases the velocity in the increasing direction, then only we are taken as acceleration as a positive. But when suddenly the bus applies the brake, the driver applies the brake, so the acceleration, the velocity of the bus is 60 km per hour. Imagine that you are in the bus moves with a velocity of 60 km per hour. Suddenly the driver applies the brake. The velocity changes to 10 km per hour. When the driver applies the brake, the velocity of the bus decreases to 10 km per hour. Here the acceleration will be in this direction and the acceleration will be in this direction and the velocity will be in this direction. In this case we are going to take it acceleration as a negative, and this acceleration is called as a deceleration. Have you got understood? It is called as a deceleration. See, velocity, the acceleration should be taken as positive if it is in the direction of the velocity, and it is taken as negative, if it is not in the direction of velocity. It is not in the direction of velocity, and that acceleration it is called as a deceleration. It is not an acceleration, it is a deceleration. Here in the deceleration case, the speed will be, the velocity of the bus will be decreases. In the deceleration case, when the driver applies the brake, the bus moves with before applying the brake, bus moves with a velocity of 60 km per hour. When the driver suddenly applies the brake, the velocity of the bus changes to 10 km, decreases to 10 km per hour. This acceleration, change in the velocity, it is nothing but deceleration. Have you got understood? It can be taken as a negative. Have you got understood? Once again I will tell here, acceleration should be taken positive if it is in the direction of the velocity, and it should be taken as a negative if it is opposite to the direction of the velocity, and this negative acceleration it is called as a deceleration. Is it clear? Okay, next I am going to discuss here uniform acceleration. What is meant by uniform acceleration? Uniform acceleration. What is uniform acceleration? You know now already what is meant by acceleration, but now I am discussing uniform acceleration. What is uniform acceleration? If an object if an object is said to be in uniform acceleration it increases or decreases its velocity by equal amount in equal intervals of time. What is the meaning of uniform acceleration here? If an object moves with the uniform acceleration, it increases the velocity or decreases the velocity in a such a way that it increases or decreases its velocity by equal amount in equal intervals of time. So what it means, I am considering one example here. A bus moves, any vehicle, I am considering one object here. An object moves with 10 km per hour. After 10 seconds, it attains the velocity of 20 km per hour. After 10 seconds, it attains the 30 km per hour. Then again after 10 seconds, it attains the velocity of 40 km per hour. See here, change in the velocity in this example. It starts with the velocity of 10 km per hour. After 10 seconds, it attains the velocity of 20 km per hour. But change in the velocity here, 10 km per hour. It increases with the 10 km per hour. Again after 10 seconds, it attains the velocity of 30 km per hour. Again change in the velocity here, 10 km per hour. And again after 10 minutes, it attains the velocity of 40 km per hour. Again here the change in the velocity is 10 km per hour. See here, at every equal intervals of time, that is every 10 seconds, it increases the velocity of 10 km per hour. Then only this object will be said to be in a uniform acceleration. Is it clear? So what is uniform acceleration here is, if an object is said to be in uniform acceleration, it increases or decreases its velocity by equal amount in equal intervals of time. Then only the object in the uniform acceleration. So is it clear? Once again, if an object said to be in uniform acceleration, it increases the velocity or decreases the velocity by equal amount in equal intervals of time. That is known as uniform acceleration. So what are the examples for the uniform acceleration? The one of the example for uniform acceleration is freely falling body. For example, you are in the plane. Imagine that you are in the plane. You just left a ball from a plane. It comes towards the Earth's surface, but when you left the ball at the point of the end, at the starting point, the velocity of the ball will be 0. But when it comes to the Earth's surface, the velocity will be very high. But it attains the velocity for every second. In equal intervals of time, it attains the equal velocity that the freely falling body in the motion of uniform acceleration. The acceleration of the freely falling body is said to be uniform. That is uniform acceleration. Why? Because it attains the equal velocity in equal intervals of time. For every second moves towards the Earth, it attains the equal acceleration for every second. So it is said to be one of the example for uniform acceleration, that is freely falling body. And another one is stone rolling down the slope. Stone rolling down the slope. Imagine that a slope is there. Imagine that just like this. A slope is there. You have a marble. If you left the marble, or if you put the marble, if you left the marble, the initial velocity of the marble is 0. But when you left the marble, it attains some acceleration. The acceleration got by the marble at every instant is equal. So therefore the acceleration attained by the marble when it is moves downwards towards the slope, it is an uniform acceleration. It is an example for uniform acceleration. So the examples for uniform acceleration, another one example for uniform acceleration is stone rolling down the slope, and another one is child coming down from a slide. So imagine that you are also playing with the slides. The child coming down from the slide, it is also one of the example for uniform acceleration. So now we are going to discuss what about non-uniform motion, what it is non-uniform acceleration, what about non-uniform acceleration. It is deadly opposite to the uniform acceleration. If an object is said to be in non-uniform acceleration, it changes its velocity by unequal amount in equal intervals of time. What is non-uniform acceleration? If an object is said to be in non-uniform acceleration, it changes the velocity by unequal amount in equal intervals of time. What are the differences here? In the uniform acceleration, in equal intervals of time, the object attains equal amount of acceleration. But in the non-uniform acceleration, the object covers or attains unequal velocity in equal intervals of time. That is known as the non-uniform acceleration. Example for the non-uniform acceleration, it is a car moving in a crowded place. It is one of the example for the non-uniform acceleration, or any example you can take. A bike moving in a crowded place, that is also, and a bike moving in a traffic place. So that is another one example for non-uniform acceleration. What is non-uniform acceleration here? It is the object attains unequal velocity in equal intervals of time. That is known as non-uniform acceleration. So based on this, now we are going to discuss some of the examples on acceleration. Take down first example. Now we are going to discuss some examples on that, numerical examples on acceleration. So first we have to remember the expression acceleration A is equal to final velocity V minus initial velocity U divided by time t. The first example, starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Then he applies the brakes. Such that the bicycle comes down to 4 meter per second. In the next 5 seconds. Calculate the acceleration of the bicycle in two cases. Solution. Once again, you read the example here. Starting from a stationary position, initial velocity will be 0. Stationary position means it will be at the rest. Initial velocity U is equal to 0. Starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second. That is, the final velocity here is 6 meter per second. V is equal to 6 meter per second. In time 30 seconds, he takes 30 seconds to attain 60 meter per second of velocity. Then he applies the brake. After attaining the 60 meter per second, he applies the brake. Then suddenly the bicycle comes down to 4 meter per second. As when he applies the brake, the velocity of the bicycle comes down to the 4 meter per second in the next 5 seconds. Calculate the acceleration of the bicycle in two cases. What are the two cases? In the first case, when the bicycle attains 6 meter per second, and also in the second case when bicycle attains 4 meter per second. Case first. Here in the case first, initial velocity U is equal to 0. Why? Because the bicycle starts from a stationary position. Stationary means from a starting position, it is the velocity of the stationary position is 0, and the final velocity that is V is equal to 6 meter per second. It attains the velocity of 6 meter per second in a time t is equal to, in how much time it takes? 30 seconds. So acceleration of the bicycle A is equal to v minus u divided by t, that is equal to, here v is equal to 6 minus 0 divided by 30, that is equal to 6 divided by 30, 6 1s are 6 5s are. A is equal to the amount, the acceleration A is equal to, here 0.1 divided by 5, it is 5 ones are 0.2 meter per second square. The SI unit of acceleration is nothing but meter per second square. And thus in the second case, case 2, here in the case 2, after applying the brake, so before applying the brake, that is the initial velocity of the bicycle, that is 6 meter per second. This is the initial velocity in the second case, case 2. Initial velocity here, initial velocity u is equal to 6 meter per second. After applying the brake, the final velocity will be 4 meter per second. Final velocity v is equal to 4 meter per second. In the time that takes the time of 4 minutes, it takes the time of 5 seconds, isn't it? Yes, 5 seconds. Time t is equal to 5 seconds. Then the acceleration in the second case of bicycle, A is equal to again v minus u divided by t. Here v is 4 meter per second minus the initial velocity 6 meter per second divided by time t is 5 seconds, that is equal to 4 minus 6 is minus 2 divided by 5, that is equal to 5 1s are 5, 0.4s are, that is equal to minus 0.4 meter per second square. This minus sign indicates that is a negative acceleration, nothing but a declaration. I have already told about you, this is the declaration, minus 0.4 meter per second square. This is the declaration of the bicycle when he applies the brake, because the initial velocity in the second case it is about 6 meter per second. When he applies the brake, the velocity of the cycle will be comes to down, it decreases, the velocity of the bicycle will be decreases. That's why acceleration of the bicycle in the second case is minus 0.4 meter per second square. The minus sign indicates the declaration, it is not an acceleration, it is a declaration, that is a decrease in the velocity. So again consider another one example on this. Second example, a bus decreases its speed. Bus decreases its speed from 80 km per hour to 60 kilometer per hour in 5 seconds. In 5 seconds. Find the acceleration of the bus. Find the acceleration. Find the acceleration of the bus. See here, these type of examples should be asked in your examination for 2 to 3 marks question. You should clearly see. So once again you read the example what they are given. A bus decreases its speed from 80 km per hour. Imagine now the bus will be moves with the 80 km per hour and it decreases to 60 km per hour in 5 seconds. So the initial velocity of the bus here, initial velocity of the bus u is equal to, that is 80 km per hour. 80 km per hour. We should convert this kilometer per hour into meter per second. How? Here see, 80 kilometer per hour into here 1000 meter divided by here 1000 meter divided by 1 kilometer into here 1 minute divided by 3600 seconds. Isn't it? What it happens? It is nothing but multiply and divide by 1000 meter, because 1 kilometer is equal to 1000 meter, 1 hour is equal to 3600 seconds. We have to convert kilometer per hour in terms of meter per second. See here, this kilometer get cancelled, and again here kilometer and this kilometer get cancelled, and this hour that get cancelled. These two zeros and these two zeros get cancelled. Remaining here is meter per second, and write down the remaining things. 80 into 10 here meter divided by here 36 seconds. That is equal to 80 into 10 800 meter divided by 36 seconds. Divided initial velocity u is equal to, if you divide this 800 divided by 36, you may get 22.2 meter per second. This is the initial velocity. You should convert, if the given data in the form of kilometer per hour, you should convert into meter per second. And again the final velocity v is equal to, given here it attains 60 kilometer per hour. 60 kilometer per hour, we should convert it into meter per second. 60 kilometer per hour into 1000 meter divided by 1 kilometer into 1 hour divided by 3600 seconds. This 20 get cancelled. This kilometer get cancelled. This hour get cancelled. We get 60 into 10 here into meter divided by 36 seconds. That is equal to 60 into 10 is 600 divide into meter divided by 36. That is, we get final velocity v is equal to 600 again 6 1 6, remaining is 40, that is 6 36, remaining 4, that is again it comes 6, that is equal to 16.6 meter per second. The final velocity v is equal to 16.6 meter per second, and the time here given, time is in 5 seconds. Time is given here. Time is in 5 seconds. Therefore, time t is equal to 5 seconds. Therefore, the acceleration of the bus, acceleration A is equal to final velocity minus initial velocity divided by time t. Here A is equal to the final velocity is 16.6 minus initial velocity is 22.2 divided by time is 5 seconds. That is equal to here 16 minus 16.6 minus 22.2 we get the result of 5.6 minus 5.6 divided by 5. Here 5 ones are 1 point remains, 5 11s are remaining 1, again it comes 10, that is 5 2s are, that is equal to A is equal to minus 1.12 meter per second square. This is the acceleration, and this minus sign indicates the declaration of the bus. This minus sign indicates declaration of the bus. So you should practice these type of examples for your examination. You have to convert, in the example if they are give the data in the form of kilometer per hour, you should convert into meter per second by multiplying and divide by. First you have to multiply 100 meter divided by 1000 meter divided by 1 kilometer into 1 hour divided by 3600 seconds, or you may directly multiply with 10 divided by 36. You may directly divide with 10 divided by 36 into given kilometer per hour, and you get meter per second. Okay, you should practice these type of problems in your home. Some of the examples are given in your textbook, and that will be helpful for your examination. So in the next class we shall continue this motion chapter, and in next class we are going to study about the graphical representation of the motion. Okay, thank you.